Hello everyone. Our topic is location based social network data generation based on patterns of life. Introduction. A social network is a structure consisting of individual users connected by a social relationship such as friendship. Social networking services build on real world social networks through online platforms, providing ways for users to share ideas, activities, events, and interests. As location is one of the most important components of user context, extensive knowledge about an individual's interest, behavior, and relationships with others can be learned from their locations. These kinds of location tagged and location driven social structures are known as location based social networks. Weaknesses of the location based social network real world datasets. Data sparsity. LBSN data exhibits an extreme long tail distribution of user behavior. In all existing available datasets, the vast majority of users has less than 10 check-ins. Besides, the number of locations visited by a user is usually only a small portion of all locations that user has visited. This results is the density of the data used in experimental studies on LBSNs to be only usually around 0.1%. Small datasets. Existing datasets used to train models are small, as detailed in section 2b. They tend to only cover a short period of time, a small number of users, or a small number of check-ins. Privacy concerns. Most LBSN data was published by users and consented for public use. However, some users may revoke this content, for instance, by deleting their LBSN account. Such changes will not be reflected in existing LBSN datasets and thus creating severe privacy concerns. Solution to the weaknesses. To overcome these weaknesses, we developed a location based social network simulation capable of creating multiple artificial but socially plausible large scale LBSN datasets. These large and dense datasets will allow the broader social and data science research communities to test LBSN related hypotheses without encountering issues pertaining to data sparsity, privacy concerns, and lack of ground truth. Applications of LBSN. Location recommendation, which leverages check-ins of users and their ratings in the user location network to recommend new locations to users. This research area not only has applications in helping a specific user to explore new places within a city, but can also help third parties such as advertisers to provide specific advertisements. A closely related application area is that of location prediction, which attempts to predict the future check-ins of users. Friend recommendation or social link prediction, which suggests new friends to users based on their similar interests at similar locations, while also having similar social connections. Other research topics with respect to LBSNs include efficient query processing, finding user communities, and estimating the social influence of users. Existing LBSN datasets. Real-world LBSN datasets are a scarce resource due to the privacy implications of making such data public. Also, service providers consider such datasets invaluable when it comes to providing a competitive product and are thus somewhat unwilling to give researchers even sizable datasets. Goala, collected and retrieved from the LBSN Goala, which was launched in 2007 and closed in 2012. This dataset has the largest social network of any public LBSN dataset, while the majority of users are inactive. After removing users with less than 15 check-ins and removing locations with less than 10 visitors, more than half of the visitors are eliminated. Foursquare. In terms of the number of users and check-ins, the largest publicly available LBSN dataset was collected from Foursquare. Yelp. A large dataset is published by Yelp as part of the Yelp Dataset Challenge. This dataset provides additional information such as user location ratings, user comments, user information, and location information.
Model logic patterns of life. The agent model logic used to generate the data is constructed based on people's daily pattern of life, supported by well-respected psychology and social science theories. Each individual is equipped with first three levels of Maslow's hierarchy of needs. The first is physiological, safety, and the last is belongingness and love needs. To satisfy their needs, agent travels to sites on the underlying road network. Agent travels on shortest path at a constant walking speed of 1.4 meter per second, regardless of traffic. The simulation stores and writes spatial and social information for each agent into large shared log files which can be analyzed offline. Framework implementation. The framework utilizes and extends the Mason, which is termed as Multi-Agent Simulation of Neighborhoods, open source simulation toolkit, and its GIS extension. GeoMason and Mason is a fast discrete event multi-agent simulation library developed in Java. It was designed to be the foundation for the sizable custom-purpose Java simulations by providing the basic runtime infrastructure for simulation development. Mason has been used in the past day to develop agent-based models to describe complex social interaction that is based on agents' location in space and time, including models for riot prediction, simulating the spread of disease and the emergence of slums in urban environments. Such simulations consider only a limited number of agents over only a few days of simulation time. One of the main challenges faced in scaling the system by memorizing all previously computed shortest path to avoid expensive recomputation. Privacy. Location sharing is an indispensable function of location-based social networking services. Users share their location by checking in or location-based social networking sites to let their friends know why they are and when. The location awareness can then form location-based social networks and enhance the user's social connection. On the other hand, while location sharing significantly enhances users' experience in social networks, it also leads to privacy and security concerns. In recent years, location privacy on location-based social networks has attracted more and more attention from both academia and industry. When using location sharing services, some users would like to share their location with friends for social purpose, while other users may believe that sharing personal location discloses one's personal preference and movement track, which may cause potential physical security risk. Therefore, it is inevitable to consider privacy control when designing location sharing application. Mobile applications have also been developed to help manage privacy of location-based social networks. To develop a location sharing application, Locanio, focusing on privacy control based on the Facebook social network. Future scope. Location-based social networking is another area which emerges very quickly in the space. Foursquare and Govalia are the prominent sites in this space. According to a recent Comscore report, nearly 1 in 5 smartphone users use check-in services and is growing. For merchants and other venue owners, Foursquare offers a free set of tools to help you attract new customers and keep your best ones coming back. Merchants can attract new customers or reward their most loyal ones by offering Foursquare mobile coupons, price or discounts. CCD is the first brand from India to do a tie-up with Foursquare to offer discount to its regular customers. For brands that are not tied to a specific physical location. For brands like consumer packed goods, TV channel, university, manufacturer, or an upcoming movie release, Foursquare provides two main marketing tools. So the first is pages and second is custom badges. This helps your consumer and fans to do interesting things in their neighborhood and communities. So these are some of the references of our research paper. Thank you.